Alrighty, class. Today, what we're working on is what we call the trigonometry ratios. Okay, trigonometry ratios are defined with three types, or three kinds of ratios. The first one, if you're looking under key point 2, is sine, which is abbreviated by sin, cosine, which is abbreviated with cos, and tangent, which is abbreviated with tan. Okay, make sure you say sine, cosine, and tangent because it doesn't make sense to say sin, cos, and tan. Excuse me, and tan. Tan is colloquially fine, but sin and cos is really not. So say sine, cosine, and tangent, but tan is fine. Okay. And so this is all the notes that we're supposed to have on this part of our notes and whatnot. And something I want to point out too is that theta, this like little like circle with a line in between the middle, is what we call theta. And you're just going to treat it like any other variable. Okay, it's just the variable for our angles. That is the kind of designation for it. But realize that it really isn't anything, any kind of specifics. It's just called theta. So you let it just be called theta. And so if we look at example 1, okay, I'm going to try to abbreviate things a little bit quicker today because I have some other work I should be getting done today. And so whenever we start with our first problem today, I'll show you the entire length of the problem of how I would address it in class. And then from then on, I'll kind of just abbreviate things. So we start from this angle theta. Okay, we want to find the sine, cosine, tangent with the angle theta. So just like any other example that we've done in the past, we're going to find our opposite first. So start at the angle, go to the opposite side here, right? Opposite side. And so we see here that 4 is our opposite side. We'll label this ops. Then we'll find our hypotenuse. Remember, the hypotenuse is either, well, not either, but it is the largest side, and it's the side adjacent or opposite from our 90-degree angle. So 5 is going to be our hypotenuse, and adjacent is going to be our 3. Something to note, though, is that adjacent is never going to be the hypotenuse. Okay, adjacent is always a leg. It will never be the hypotenuse. So don't get that confused. This is what we have so far. Then, whenever we take our sine, cosine, and tangent, let's first start with sine of theta. And sine theta says we're going to take the opposite over hypotenuse. So we'll write opposite over hypotenuse. And we'll do the rest so far. Cosine theta is equal to the adjacent hypotenuse. And then our tangent is our opposite over adjacent. Like so. And this all comes from this core concept here, where we have the length of the leg opposite, the length of the hypotenuse, and blah, 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 all that stuff. Okay. But here we can make it a lot more abbreviated. So after we have this, we say, well, I know that my opposite is 4. So we'll replace it. 4, hypotenuse, 5. And that's our answer. Sine of theta is 4/5. Do the next one, cosine. Adjacent is 3, opposite, or hypotenuse rather, is 5. That's my answer again. And I do the same thing for tangent. Opposite and adjacent. Opposite is 4, and adjacent is 3, and that's my answer. Okay, so actually it's a lot easier than we may think. Try extra example 1 on your own, then come back. We'll find our opposites. We'll find our hypotenuse. So here's our opposite of our theta. Here's our hypotenuse. And this must be our adjacent. And we're going to do the same thing. So sine of theta, cosine of theta, and tangent of theta. Like so. I know sine is our opposite over opposite over our hypotenuse. So opposite, which is 12, hypotenuse, which is 13. That's my answer. Cosine is my adjacent over my hypotenuse. So adjacent is 5. hypotenuse is 12, and tangent is my opposite over adjacent. Opposite is 12, adjacent is 5. That's my answer. Now, whenever I took geometry, we had to actually memorize this stuff. So all the opposite, adjacent, hypotenuse, and everything. And so by then we had created the acronym SOHCAHTOA. And here you can see exactly what SOHCAHTOA actually means. So refers to sine, ka corresponds with cosine, and toa will correspond with tangent. Okay, so we have these three to help us memorize it. And in addition to that, we have it on our reference sheet. It's actually the right triangles section of our reference sheet. And it tells us exactly what we need for sine, cosine, and theta as far as trigonometry ratios go. Okay. Example 2 here, we're just taking specific ratios of certain angles. So if I want tangent of theta, I know I want the opposite over the adjacent. But just like anything else, I want to make sure that I'm actually solving this correctly. So if I have sine, or sorry, if I have theta right here, my opposite is 8. And my adjacent is going to be 6 because 10 is my largest. And so I get 8 over 6, which can reduce down to 4 over 3. Okay. And again, we know this because 10 is our hypotenuse, because it's the opposite side of our 90 degrees. But of course, we keep going. We have sine of 45. Sine of 45 is our opposite over hypotenuse. So we had to figure out which one is which. So this is our angle. We need to find the opposite. That would be our 2. And find the opposite side of our 90 degrees. This is our hypotenuse, which means that this other 2 is our adjacent. Not that it really matters per se, because, well, it's all the same. That's okay. And so if I were to replace these values, I have 2 as my opposite over my hypotenuse, which is 2 square root 2. And this, of course, equals sine of 45 degrees. But realize that I have a ratio or a radical under my denominator, and I don't want that. So I'm going to rationalize. Realize that I'm not going to multiply a 2 from the original. So if I were to mark this, because you obviously can't see this, but if I were to multiply this 2 into a ratio, or a radical rather, I can't actually do that. Okay. And so here I have the radical times the radical times the other 2. So it would be 2 times the result of what the radical is. But any radical times itself is going to be the radicand. We just get 2. Realize that we have multiple 2's here. We can cross that 2 out. We get the square root of 2 over 2 is equal to sine of 45, which is actually a really funny thing because this is a math concept that you won't learn in geometry, but definitely in upper level math like calculus or pre-calculus. And so we keep going. Again, pause these whenever you think, or what you should pause these before every example, see if you can do it first before you watch this. But if you're still confused, you can keep watching. 30 degrees is here. I'm working with cosine, which means I want my adjacent over my hypotenuse. So I got to figure out what is my adjacent. I got to figure out what is my hypotenuse. Obviously, away from 30 is my opposite. So this is opposite. Then that must mean that the 8 square root of 3 is my adjacent, and that 16 is my hypotenuse. And so I plug those in, and I'm going to get 8 the square root of 3 over 16. And because it's already rationalized to the simplest form, we can just leave it like that. Or sorry, the rationalization is fine. However, we can simplify the coefficients, which we would then get the square root of 3 over, not 16, sorry, over 2. And that is what cosine 30 equals. So pretty good. We have example 3 here. And for example 3, we have to round to the nearest 10. You gotta be really careful here. First, what I recommend is labeling. Do the exact same thing that we've been doing before. Take this angle, which is our 32-degree angle, go opposite. So 11 is our opposite. Start from the right angle, go to the opposite side. That's our hypotenuse, which means that our x here is the adjacent. And we have to determine, well, am I going to use cosine, tangent, or sine here for solving what the value of x is? Notice I don't care about anything else. I just want the value of x. So don't make things more complicated by saying, oh, I'm going to find the hypotenuse too. There's no need for it. Okay. But because we have the opposite and we have the adjacent, we're going to find one of the 3 ratios that has opposite and adjacent, which of course is going to be our tangent. So tan of 32 is equal to my opposite, which is 11, over my adjacent, which is x. And now I'm going to solve for x. Well, a lot of us want to multiply by 11, and that doesn't make any sense. Okay, don't multiply by 11. Don't divide by 11. It's just not going to make sense. Multiply by x to get x by itself. Okay, which sounds counterintuitive, but you'll see why. If we multiply the x's, these ones are going to cross or cross each other out. We get x times tangent of 32 equal to 11, and then we're just going to divide by the tangent. Don't make things more difficult on yourself. Okay, so tangent of 32. And what we get as a result of this is x equals 11 over tangent 32. Okay. Before you solve this on your own, okay, you must make sure your calculator is in degrees. Okay, if you're using Desmos, look for the wrench in the top right and make sure you highlight degrees. Okay, it'll like black out, and that's whenever you know it's going to be degrees. If you are using your graphing calculator, if you have the ones that is recommended for you to get for algebra 2 or and up higher for math, then you should have something that says at the very top RAD or DEG. If it says DEG, that means degrees, you're good. If it says RAD, that means radians, and you're not good. You're going to use the mouse, you're going to click on that, it'll change to degrees. It'll make things easier. And you'll find right answers. So here you should get 17.604, but of course, it says round to the nearest 10th. The nearest 10th would be 17.6 units, and that's our answer. Extra example 3 is very similar. Okay, we're going to solve for t, find the value of t, round to the nearest 10th. Here I have 65 degrees, opposite side. T is my opposite side here. So let me just go ahead and erase all that. Opposite side. From my right angle, I have my hypotenuse. And the last one is going to be our adjacent. We don't have adjacent, we have opposite and a hypotenuse, which means we're going to be working with sine. Sine of 65 is equal to the opposite, which is t, over our hypotenuse, which is 8. And we're just going to solve for t. This one's a bit easier. We just multiply by 8 on both sides. These two will cancel. We get t is equal to 8 times sine of 65. And you should get the value of, I believe, something like 7.25 or something like that. But again, it also still says to round to the nearest 10th. So your answer should be 7.3 in this case units. Okay. This think pair share, you're looking down from a bridge at a duck in the water below. What would you call the angle created by looking at the duck? An angle of elevation or angle of depression? For this first question, you're going to say angle of depression. And then for the second angle, you're going to say this is what we call the angle of elevation. Make sure that I write cleaner like that. Elevation. Okay. So in the scenario, this is you angle of depression, and this is the duck angle of elevation. And we'll see it in this example here, okay? In this example, we have 59 degrees and we're looking up at the top of the tree, but we know we're also 45 feet away from the tree. And so let's go ahead and find all those things that we need to find. I'm going to use different color so that we can see it on the picture. If I start at 59, this is our angle. I go across, find my opposite. H is our opposite because H is our height. Start at my 90-degree angle, work to the other side. This is my hypotenuse. That must mean that my adjacent is 45 feet. Well, I have opposite is what I'm looking for, and I have adjacent. The only one that makes sense for this problem with the only ratio is going to be tangent. So tangent of 59 degrees is equal to the opposites over the adjacent, which is opposite is H, and our adjacent is 45. So much like the previous problem, we're just going to multiply by 45 on both sides. That's going to cancel. We're going to get 45 times tangent of 59 equal to H. Okay, if you have any issues with your trigonometry, okay, what is recommended is putting these parentheses around it because it makes it tells the computer or the calculator or the computer inside the calculator, rather, I should say, that you're looking at only tangent of 59 and not like tangent of 59 times 45, for example. Okay, you want to make sure that you put this in parentheses to make things a heck of a lot easier for you. And so whenever we get this problem done, we put that into a calculator. We get H equals 74.89 feet. But make sure you read the problem and once the nearest foot. So we're going to get H equals 75 feet, which means that the tree is 75 feet tall. Okay. And the last example here, again, really pushing the pace here because I have to do something during this period. But here it already tells us that we have an altitude of 1,200 feet and the angle of depression is 21 degrees. Find the distance X you see down the mountain to the nearest foot. So if I'm starting at this slope here, 21 degrees, go opposite away from it is 2,100 or 1,200 rather, I should say. This is my opposite. Start at my 90-degree angle here on the right side, go to the opposite side. This is my hypotenuse, which means that this top side is our adjacent. Okay. So this is what we have so far. Think about which of our ratios have a opposite and a hypotenuse, and that should be pretty easy. We know that the sine is going to have opposite and hypotenuse. So we should have sine of 21 equals our opposite, which is 1,200, over the hypotenuse, which is x. So much like that problem from the very beginning of the class, or not the very beginning of the class, but towards the beginning of this lesson here, we got to multiply that x. Okay, it's just going to make us, it's just going to make more sense to us, okay? There's another way around it. We get x times sine 21 equals 1,200, where we cross those x's off, and then we're just going to divide by sine of 21 on both sides. So we should get x equals 1,200 over sine of 21, which means that we get an x value of, I believe, 3348.514. But it says to the nearest foot, so we should have x equals 3,349 feet. And that is our lesson today. Okay, a lot of it is heavy on the math stuff. So as long as you're able to decipher your opposite, adjacent, and your hypotenuse, realistically, you should be fine. Okay, you have the reference sheet. It tells you exactly what to do with the sine, cosine, and tangent, but you really have to identify those opposite sides. Okay, otherwise it's just not going to work. Okay, so make sure that you're studying. Remember, we have an exam this week, and I hope you have a great rest of your day. I will see you all later.